Mr. Kaczynski here, and we're going to simplify radical expressions today, a mixed review. This is the last skill in section EE. Don't bother with this one if you haven't mastered many of the ones prior to it. Alright, because we learned a lot. Here we go. Very basics here. Simplifying radicals is all about looking for perfect square factors like 4. 4 times 7 is still 28, but 4 is a perfect square. Square root of that 4 is 2, so we could rewrite this as 2 times the square root of 7. Alright, so there's some basics. This is similar to that, but it involves variables. So 147 is divisible by a perfect square, 49. So 49 times 3. And g to the 10th, that is a perfect square, so we'll just leave it. Alright. Square root of 49 is 7. Square root of g to the 10th is g to the 5th. And then we've got the square root of 3. So 7g to the 5th times square root of 3 is the simplified version of that expression. Adding and subtracting square roots expressions, just remember this is a 1 first of all, so we're just doing 1 minus 9 is negative 8 times the square root of 7. They have to have the same square root to be added or subtracted. If they don't have the same square root, you can't, but that's pretty simple. Now distributive property, so we get into some multiplying. Alright, negative square root of 2 times negative 8 is positive 8 times the square root of 2. And negative square root of 2 times negative square root of 5 is positive square root of 10. Those don't have the same square roots, so they cannot be combined any further. Now 35 over 175 can be simplified, so the first thing I'm going to do is write this as the square root of 1 over 5. Alright, now I need to rationalize my denominator. And what I mean by that is I can't have any fractions in my square root sign. I also can't have any radicals in the denominator. So if I multiply this by the square root of 5 over square root of 5, that's 1. It won't change its value, but it will change the way it looks. So on top, square root of 1 times square root of 5 is square root of 5. And on the bottom, the denominator, square root of 5 times square root of 5 is 5. That is our simplified answer. So now we don't have any fractions in the radical, we don't have any radicals in the denominator, and also the radical in the numerator, that 5, it does not have any perfect square factors. Same idea here. Let's simplify inside the fraction first. So we could rewrite this as the square root of 3 over 4y to the 6th. Because 8 minus 2 is 6. And then take the square root of the numerator, which is the square root of 3, and the square root of the denominator, which is 2y cubed. Again, we don't have any fractions in the radical. The denominator doesn't have any radicals in it, and the number up top that's inside the radical, that 3, doesn't have any perfect square factors, so we simplified it. Then we have a complex number, negative 8 plus the square root of 5, in the denominator. Again, we can't have radicals in the denominator, so we use the sum and difference pattern to simplify this radical, or to get rid of that square root. So if we multiply by negative 8 minus the square root of 5, as opposed to negative 8 plus the square root of 5, then we can use the difference of squares. I'll explain. Whatever you do to the bottom, you have to do the top, though. Alright, so on top, square root of 3 times negative 8 is negative 8 times the square root of 3. Square root of 3 times negative square root of 5 is negative square root of 15. All over, okay, so a plus b times a minus b should be a squared minus b squared. So in other words, we take this negative 8, we square it, that's 64. And then we take the square root of 5 and we square it, and that's 5. Nothing can be simplified in the numerator, and so we'll just rewrite it. Negative 8 times the square root of 3 minus the square root of 15. but we'll simplify on bottom. 64 minus 5 is 59. And that's it. I did look for common factors that I could simplify, but there are none. Multiplying binomials. All right, well, we'll do 9 times 4 is 36. And then we'll do 9 times the negative square root of 3, which is negative 9 square root of 3. Then we'll do square root of 3 times 4, which is 4 times the square root of 3. And square root of 3 times negative square root of 3, which is just negative square root of 9, or negative 3. There are some things that can be combined there. Oh, and the 36 minus 3 can be combined, can it? 36 minus 3 is 33. And negative 9 square root of 3 plus 4 square root of 3 is negative 5 square root of 3. And that's as far as we can simplify this one. Just a couple more. This could be set up just like the last one, but I think I'm going to use the square of a binomial pattern. So whenever you're squaring a binomial, it fits this pattern of a squared plus 2ab plus b squared. So I'm going to take negative 10 times the square root of 3 and square it. And then I'm going to do 2 times that negative 10 square root of 3 times the second term, which is negative 6 square root of 7, plus b squared, which b is negative 6 square root of 7. And I'm going to square that. All right, so negative 10 squared is 100. Square root of 3 squared is 3. So this is 100 times 3 is 300. Over here, we've got 2 times negative 10 times negative 6, negative 20 times negative 6, which is positive 120. And also the square root of 3 times the square root of 7 is square root of 21. And then this last term, negative 6 squared is 36 times 7, because the square root of 7 squared is 7, is 252. I do have some like terms that can be combined. The 300 plus the 252 makes 552. So 552 plus 120 times the square root of 21. That cannot be simplified because the square root of 21 doesn't have any perfect square factors. Last one, like I said, there's a lot that was in this unit or section of IXL. All right, I'm going to write this as one big term here. So I've got my 10 outside the radical. 12 times 7 inside is 84. And the g to the 6th. G times g to the 5th is g to the 6th. 84 can be expanded and written as the product of two factors where one of the factors is a perfect square. 4 times 21. 4 is a perfect square. And then we got our f to the 4th and our g to the 6th. Those are both perfect squares. So 10 times the square root of 4, which is 2, times the square root of f to the 4th, which is f squared, times the square root of g to the 6th, which is g cubed, times the square root of 21. And obviously this can all be simplified a little bit. 10 times 2 is 20, times f squared, times g cubed, times the square root of 21. A lot of stuff we learned with simplifying radicals in section EE. Good luck to you, and let me know how it goes.